Welcome to section 4.7, predicting with linear models. So remember last section when I talked about everyone's lines of best fits will be different if they're doing it by hand? Computers can generate an actually accurate line of best fit that will be consistent across different models, across different people doing the same, working with the same data. And when computers do this, it's called running what's called a regression. So it takes your data, runs a regression, and spits out an equation for you. And it can do this with a lot of other things that aren't just linear, but we'll get to some more of those later on this year and also in Algebra 2. So first thing we need to do is plot and run a regression. Well, for this, what I'm going to look at first is, let's go ahead and pull out our graphing calculator, and so I can show you how to plot and run this regression. So pulling out our graphing calculator. Oops, don't actually need to graph it at the moment, so let's second quit. So if you're going to plot your points, first thing you need to do is go to Stat, and then this very first option, Edit, so you can just hit Enter. What these lists are here is your list 1 is going to just automatically run as your X coordinates, and list 2 will be your Y coordinates. So you want to make sure you get your X coordinates and your Y coordinates right next to each other. Now, the data that we're working with, we're looking at years since 1993 because that was our first year of data. So I'm going to actually think of renumbering this a little bit. So just so you can see it, I'm going to put them here, but this isn't actually where we would want to put our years. But we're going to have 93, 95, 96, and 97. So these are the 4 years that our data comes from. But since we're looking at stuff in terms of years since 1993, the X values that we're going to use will be 0, because we're 0 years from 1993, 2, because 95 is 2 years after 93, 3, because that's 3 years after 93, and 4, because that's 4 because 97 is 4 years after 93. So that's one way that you can go and just enter in your data. So you type in your number and then hit enter. Now, if you need to go and get rid of some data, if you want to get rid of a singular point, let's say I didn't want this 95 here, you can press this delete button and it will delete that individual data point. If you want to get rid of that whole column, you would scroll up to L2 and then hit clear and hit enter. I will warn you, do not go up there and press delete, because if you do that, you will delete the entire list of L2. And so suddenly you now have list 1 and list 3. And your calculator is now going to make you jump through weird hoops in order to do that. So if you end up doing that, what I would suggest doing is just go ahead and delete your other lists just to get that all cleared out. So now you have list 1 and then nothing. At this point, you can go and press second 2 to rename that list L2. And then you can go to the right one and press second 3, which will rename it L3. And then you can do that all the way through list 6, just to get them back in order. It's very rare that you will ever need more than 2 lists, but it's helpful to be able to rename them if you accidentally goof up there. So anyways, we've got our 4 X values, and our Y values for these were the points 7.8, because in 93, at time 0, we had 7.8. Then at time 2, we had 22. At time 3, we had 43. And at time 4, we had 67. Now, if you want to get out of here, clear doesn't work because it's not doing anything. So you have to remember that above mode is that quit option. So you can press second quit. Now, if you want to actually graph these and make a scatter plot on your calculator, you can do that. So above y equals is stat plot. So you're just working in stat. So you're plotting things from stat. And what you want to do is hit here on plot 1, hit enter, and then hit enter again to turn it on. And if you notice, on this operating system at least, it says that your x coordinates are from list 1, your y coordinates are from list 2. The other thing you're going to have to do is go to your window and adjust your window to make sure you get all your numbers to fit. So our numbers ran from 0 to 4 for our x's, so I'll probably just go from -5 to 5, just so that I know that everything's encompassed. And our highest value went up to +67. So I'll keep our y minimum at, I'll go for -5 just so it sort of matches, but you don't want to go exactly 0 because then all of a sudden your axis is like almost out of the window and it's hard to see. But our y max, let's go up to 75 because that's more than 67. And now we can go and press graph and you'll have our 1, 2, 3, 4. We have our 4 plots plotted, or 4 points plotted. So that lets you be able to see them. If you ever want to undo that so you don't have to see them, you can go back to second stat plot, and that fourth option down is plots off. So if you hit 4 and then hit enter, it will turn off the stat plots so you won't see those points anymore. At this point, if you go back to this graph and you want to just get back to going from -10 to +10 in both x and y's, you can also press zoom and then press 6 to get you back out to just that regular -10 to +10 graph in both directions. Now, so you plotted those, now you need to actually figure out what is the regression. So the linear regression in this case, you can go back to stat, and this time we're going to go right over to calc. So you go right, and that fourth one down, linreg, that stands for linear regression. So you can go ahead and press 4, hit enter. On the newer operating system, you might actually have to go down to the bottom of a list and hit calculate. But at the end, it should give you something that looks like this. Y equals ax plus b, so it's telling you the format of your equation. And then it tells you that a is going to equal this, and b is going to equal that. So, since we knew that in this case, it was y equals ax plus b, and it then tells us our a, we can know that y equals 14.45x plus 2.43. You can just round it to a couple decimal places. At this point, it can go, you can use this equation to help model and predict what will happen again in the future, or with years that you don't have information on. So like 94, that's 1 year later, or 1 year after 93. So you can go and plug in a 1 for x and figure out what other information you have. Now, if I'm using my calculator to run this regression anyways, if I'm going to find more data, I will likely also do that from my calculator. So I'll come back to stat plot, or sorry, to y equals, just so I can graph this line that we just came up with. So it's 14.45x plus 2.43. And I'm going to go to my table, so second graph, because I want to know at 1 year, how many, or how big was it? Well, at 1 year, it's 16.88. We also need to know a 98, which is 5 years in. So 5 years in, we'll be at 74.68. And at 7 years, for 2000, we'll be at 103.58. So now that we could use our calculator to find this information, let's go ahead and try solving the next problem. So this next problem is about the number of participants in a youth softball in the United States from 1997 to 2001. We want to use this to predict, and this is, the years are across the top, the participants here are in millions. So that's 1.44 million people playing softball for that very first number. So we need to use this to predict the year in which the number of youth softball participants reaches 1.2 million. Because looking at these numbers, they're going down. And so we're wondering, when is it going to be 1.2 million participants? Let's go and use our calculator for this. So as a reminder, you want to go into Stat and Edit in order to plug in these points. And to clear them out, you just go up to the top and hit Clear, then Enter. Then over to the other one, Clear, Enter. So we're looking at this in terms of years since 1997. So 97 was year 0, 98 was year 1, 99 was year 2, 2000 was year 3, and 2001 was year 4. Now for each of those, we do have an x-coordinate as well, so it's 1.44, then just 1.4, then 1.411, 1.37, 1.355. Okay, so now I've got our data entered into the calculator. You can go second mode to quit out, and you can now run your linear regression. So again, go to Stat, go to the right up to Calc, and then the fourth one down is LinReg, or linear regression. Hit enter. We have our A and our B. So now what I would do is I would go and plug these numbers into my y equals. So A equals negative 0.02, B equals 1.4352. So I'll come up here and go y equals negative 0.02x plus 1.4352. And we can go and look at our graph. And you can see it's slowly going down, but not all that fast. And the question was asking, when will it equal 1.2 million? Well, looking at the graph, it's not actually all that helpful. Like, I can't just look at this and see. So as much as I don't want to, I'm going to actually try to maybe figure this one out by hand. So let's go back to our paper. So in this case, we know our A and our B, so we can just do y equals negative 0.02x plus 1.4352. And we want to know, when does y equal 1.2? So we can go and actually replace our y here with that 1.2 and solve for x. So subtract the 1.4352 from both sides, which comes out to be negative 0.2352. That's going to equal negative 0.02x. So now we can divide by that negative 0.02 on both sides. And we're going to come out with an x equals, divide by negative 0.02, x equals about 11.76, or about after 12 years. Now, if we were to have actually finished solving that off of the graphing calculator instead, and we know now that it's going to be at about 12 years, our window wouldn't have been big enough here because it only goes 10 out. So you would have actually had to go a little bit further. So let's say, maybe I'm just thinking realistically, it's probably not going to be more than 30 years out. So we'll just go for an x equals 30, pretending that I don't know the answer yet. Now, if I were to graph this, we can still see it's going down. But when does it equal 1.2? Well, we can come back to y equals. And in that second line, y sub 2, we can just graph 1.2. So now we'll have this other line cut straight across here. That's 1.2. Well, this is hard to see because those are really close together. So I'm actually going to adjust my y window. So we will go from 0 up to, well, let's just say 2, because we know it's going to be between 1.2 and something. So now we have our 1.2 cutting across here and our other line coming down. You can find that intersection point by going second calc, go down to number 5, which is an intersect option. And it's asking about our first curve, or what line do we want to see where it intersects. Well, I can't tell which that cursor is currently on, so I'm just going to go to the left a little bit. And it looks like it's cutting down on that diagonal one. Yeah, that's one of the two that we want, so I'll hit enter. And we want to know when does it intersect this straight line? Well, not just jump down to that one. So I can hit enter again and hit enter once more. And again, we get 11.76, which would round to 12. So two different ways, we still got the same answer that it's going to be after about 12 years. Now, there's another thing called a zero of a function. And the zero of a function is just finding what is the x-intercept, or wherever this graph is at, where does it come down and have a value of 0 for the y? Well, we can do that with this type of equation too, except now it's not going to be solving for 1.2, it's going to be solving for 0. So we can do it using the same math by hand. So let's say we had 0 equals negative 0 or 0.02 x plus 1.4352. We can subtract that to the other side, so I have a negative 1.4352 equals negative 0.02x, divide by negative 0.02, divide by negative 0.02, and we come out with an x equals, I've got it written down over here, x equals about, so we should actually use these squiggles, about 72 years. Now, if we were to go and do this with our graphing calculator, we would have to mess with this a little bit more, because at the moment we're stuck between +2 and 0, and we're only looking about 30 years into the future. And as you can see, right here at that 30-year mark, it's well above the 0 mark. So we're going to have to mess with our window a little bit more. So let's just say we'll go from -10 so we can still see that y-axis, but let's go all the way out to, I don't know, maybe 100 years into the future should be enough. And we also know from having solved this the other way that it's at 72 years. So 100 years should definitely be enough. Now, the biggest thing is we need to be able to see that 0, or where does it cross the x-axis. So I don't want it to actually be at 0 for that, because I want to be able to see the axis. So let's go down to -2, just to make it just more obvious. I'm also going to come back and just delete that second line, because I don't actually need that here when we look at this, because I just want the one line. So when I come back, we can now see our graph come and graph all the way on down. And clearly at some point it crosses that x-axis and gives us that 0 value. Well, if you want to solve that using your graphing calculator, you can go second trace to get that calc function again. And we want to go for 0, that second option. Now it wants us to say, tell us what side of this line is to the left of that 0. So if we're going left from this 0, this point is to the left, so I'll hit enter. It then wants us to go to the right of that 0. So I'm going to go, just keep on clicking to the right until I'm for sure to the right of that 0, which now I'm on the negative side. We're down here to the right, so that's definitely going to be good. And guess doesn't actually matter right now, so we'll just hit enter. And we come out with a 0 at 71.76, or about 72 years. So hopefully that's enough to let you figure out how to tackle these types of problems using your graphing calculator. For my class, I am totally okay with this section if you make your scatter plot all on your graphing calculator. I don't need you to draw that on your paper. I will keep you good on the honor system that you are promising to me that you're doing this on your graphing calculator. For other people's classes, if you happen to be watching this on YouTube, no guarantees as to what your teacher wants you to do, but for my class, you can graph all of your scatter plots for this section on your graphing calculator. Other than that, good luck, and as always, let me know if you have any questions.